Every night, it watches us, silent, ancient, familiar. And yet, the story of the moon did not begin in silence. It began in fire, in violence, in one of the most catastrophic collisions in the history of our solar system. Before oceans, before continents, before life, a world was destroyed so another could be born. This is the moon. Nearly 4.5 billion years ago, Earth did not look blue. It had no oceans, no continents, and no life. Its surface was covered in magma, its atmosphere toxic, and its young crust constantly reshaped by endless impacts. Around the newborn sun, planets were still forming through collision and chaos. Nothing in the inner solar system was stable. Massive planetary embryos crossed unstable orbits, competing for space, mass, and survival. Among them was a growing molten world that would eventually become Earth. But Earth was not alone. Somewhere nearby, another world was forming. Similar in composition, similar in size, and moving silently through the same cosmic neighborhood. For millions of years, these two worlds shared the same destiny, without knowing that one of them would soon disappear forever. Scientists believe the second world was roughly the size of Mars. Today we call it Theia. It may have formed near Earth's orbit, sharing similar material and gravitational influences. For millions of years, both worlds traveled around the sun in delicate balance. But in the young solar system, balance never lasted. Small gravitational shifts slowly changed Theia's orbit. A few degrees became thousands of kilometers. Thousands became millions. And eventually, the two worlds began moving toward the same point in space. There were no warnings. No time to escape. Only gravity, quietly bringing two planets toward an unavoidable collision. When Earth and Theia finally collided, the energy released was beyond anything humanity has ever witnessed. Two planetary worlds, moving at tens of thousands of kilometers per hour, struck each other in a collision so violent that entire layers of rock instantly vaporized. Oceans of magma exploded into space. Planetary crust became plasma. Shockwaves traveled across worlds still being born. But Earth survived. Damaged, melted, reshaped. Theia did not. Most of its structure was destroyed, mixed with Earth's outer layers, and thrown into orbit as billions of tons of superheated debris. For a brief moment, Earth was surrounded by a ring of fire, an orbiting cloud of molten rock and vaporized worlds. And from that destruction, something new began. The debris surrounding Earth did not stay chaotic forever. Gravity slowly began pulling fragments together. Rock collided with rock. Fire met fire. Orbit after orbit, the molten material became denser, larger, and more stable. Over time, a new world began taking shape. Not captured from deep space, not formed independently, but born directly from Earth itself, the moon. A world created from planetary destruction. A silent companion forged from violence. And although it looked lifeless, barren, and cold, its existence would soon shape Earth's future in ways far more important than anyone could have imagined. Today, Earth spins with remarkable stability. Our seasons change gradually. Our climate follows predictable cycles. Our axis remains tilted at nearly 23 degrees, stable enough for ecosystems, oceans, and life to evolve over billions of years. But that stability may not exist without the moon. Earth is not a perfect sphere. It wobbles as it spins through space, constantly influenced by the gravity of the sun and neighboring planets. Left alone, that wobble could become chaotic over millions of years. Entire climate systems could shift dramatically. Ice ages could arrive without warning. Deserts could replace oceans. But the moon's gravity acts like a stabilizing anchor, quietly holding Earth's rotation in balance year after year, age after age. When the moon was young, it orbited far closer to Earth than it does today. Its gravitational pull was stronger, much stronger. The oceans that would one day cover our planet rose and fell in enormous tides, hundreds of times more powerful than the ones we know today. Entire coastlines disappeared beneath moving walls of water. Newly formed continents were flooded, exposed, then flooded again, day after day, century after century. But these violent tides may have done something extraordinary. By constantly mixing minerals, heat, salt, and organic chemistry along shallow coastlines, the moon may have helped create the perfect environment for early life to emerge. Long before life could walk, it may have first needed the pull of the moon. Earth did not always rotate once every 24 hours. In its early history, our planet may have completed a full rotation in only 5 or 6 hours. Days were shorter. Sunrises came faster. Nights disappeared almost as quickly as they arrived. But every orbit of the moon slowly changed that. Through a process called tidal braking, the moon's gravity continuously pulled against Earth's rotation, stealing tiny amounts of energy over billions of years. The effect was almost invisible in a human lifetime, but unstoppable across geological time. Slowly, Earth's spin began to slow. Days became longer. Climate patterns stabilized. Biological rhythms evolved. Even the concept of a day as humans understand it now may exist because the moon refused to let Earth spin too fast. Scientists still debate exactly how important the moon was to the emergence of life. But one fact remains difficult to ignore. Without the moon, Earth would be a very different world. Its axis could drift chaotically. Its climate could become unstable. Its tides would weaken. Its rotation would remain faster. And the delicate balance that allowed oceans, continents, weather systems, and life to evolve might never have existed at all. The moon does not protect Earth with force. It protects it with patience, quietly, invisibly, orbit after orbit, billion after billion years. Which raises a simple but uncomfortable question. Without the moon, would humanity ever have existed? For thousands of years, the moon was a mystery, close enough to see, impossible to touch. Then in 1969, humanity changed that forever. During the Apollo 11 moon landing, humans stepped onto another world for the very first time. What looked smooth from Earth revealed a landscape of sharp dust, ancient craters, and billions of years of untouched history. For the first time, the moon was no longer a distant light in the night sky. It became a place. For decades, scientists believed the moon was completely dry, a dead world of dust and stone. But modern missions changed that assumption. Deep inside permanently shadowed craters near the lunar poles, instruments detected something extraordinary. Water ice, hidden in darkness so cold that sunlight has not touched some regions for billions of years. Frozen history, frozen resources, and possibly the key to humanity's return. Because on the moon, water is not just science. It may become survival. Today, the moon is no longer just a destination from the past. Through programs like NASA's Artemis program, humanity is preparing to return, not for days but for years. Habitats, power systems, scientific laboratories, perhaps even permanent settlements. What was once the final frontier may soon become humanity's first world beyond Earth. And once again, the moon may shape our future, just as it shaped our past. It looks silent, lifeless, familiar. But the moon is far more than a satellite. It is the product of planetary violence, the stabilizer of Earth's climate, the architect of our tides, the witness to our history, and perhaps the first step toward our future among the stars. Long before humans looked up, it was already there, silent, ancient, waiting, not just above us, but with us.